Today we're going to talk about dividing powers. So we're going to start with a little investigation to see what happens when you divide powers with the same base. So we're going to start with 3 to the 5 divided by 3 to the power of 2. So I'm going to actually work out what 3 to the power of 5 is and what 3 to the power of 2 is. So 3 to the power of 5 is 243. And then 3 to the power of 2, I already know that one. That's 9. Now 243 divided by 9 is 27. Now I've been working with exponents long enough to know that 27 is actually 3 to the power of 3. So this is the same thing as 3 to the power of 3. Now I'm going to try same idea, but with a different question. So I have 6 to the power of 7 divided by 6 to the power of 3. So once again, I'm going to use my calculator to help me do 6 to the power of 7. And I get 279,936. And then that is divided by 6 to the power of 3 is 216. So 279,936 divided by 216 is actually 1,296. Now 1,296 is actually the same thing as 6 to the power of 4. So I'm going to ask you to take a second, and I would like you to look at the original questions. So I have 3 to the 5 divided by 3 to the 2, and 6 to the 7 divided by 6 to the 3. And I want to know, can you see a way for us to get to the final answer of 3 to the 3 or 6 to the 4 without having to do all the middle calculations? I'm hoping that you noticed that 5 take away 2 is 3, and 7 take away 3 is 4. So when you divide two powers with the same base, and they have to be the same base, exponent laws only ever work if they're the same base because it's all about repeated multiplication. So you need to be multiplying or dividing the same number over and over and over again. If you divide two powers with the same base, you leave the base the same and subtract the exponents. So we're going to give those rules a try. We're going to do a couple of different examples to see if we can practice using our new rule for exponents that says when you are dividing two powers with the same base, you leave the base the same and subtract the exponents. So our first question says simplify. Now when a question says simplify, it means it wants you to still write your answer as a power. If the question said evaluate, that would tell me that I should actually be working it out on my calculator. So 2 to the power of 7 divided by 2 to the power of 5. So they have the same base, so the base stays the same, it's still a 2, and then I would subtract the exponents. So 7 take away 5 gives me 2 to the power of 2. Now, do you need to show that middle step? No, it's optional. But I like to put it in my lessons so that you know where my work came from. I'm going to take a look at the next question. Now, the next question involves a little practice of the rule we learned yesterday on multiplication. So I have x to the power of 15 times x to the power of 11 divided by x to the power of 7. So I notice that I have some multiplication in the numerator, and then I have some division. Now, when I'm trying to decide what to do first, I will normally simplify the numerator and then simplify the denominator, and then do the division from there. So I'm going to start with x to the 15 times x to the 11. So we learned yesterday that when you multiply two things with the same base, you leave the base the same and you add the exponents together. So 15 plus 11 gives me 26. So I didn't write 15 plus 11. I actually just did the addition in my head. You can use your calculator to help you do it. And then this is divided by x to the power of 7. And then when I go to do the division, x to the power of 26 divided by x to the power of 7, they have the same base. It stays in x. That doesn't change. And then 26, I don't divide 26 by 7. I subtract them. So 26 take away 7 is 19. So I get x to the power of 19. Now you'll notice when I did this example, I didn't show the steps. So if you want to put the extra steps in, that's fine. But if you don't want to show the extra steps, that's also okay. But I do at least need to see where you did your multiplication and then where you did your division, right? I don't just want a final answer. I want to see some steps there. So our last one, I have 4 to the power of 14 times 5 to the power of 20 divided by 4 to the power of 8 times 5. Now, in this one, I simplified the numerator by multiplying these together. So can I multiply 4 to the power of 14 and 5 to the power of 20 together? And the answer is no. So these have different bases. So 4 and 5 are not the same base. They have exponents, right, which means these are bases, so I cannot multiply them together. They're not coefficients, right? They are bases with an exponent on them, and since they're not the same base, I cannot multiply them together. In the denominator, same thing. I have a 4 with a power on it, and I have a 5. They are not the same base. I cannot do anything with them. I cannot multiply them together. So what I am going to do is try to do the division. And I am going to do the 4s with the 4s. And I'm going to do the 5s with the 5s. So 4 to the power of 14 divided by 4 to the power of 8, I would subtract those exponents. 14 take away 8, oops, I hit divide by accident, is going to give me 6. Then that's times, you'll notice these were being multiplied in the top, so they're still being multiplied down here. 5 to the power of 20 divided by 5. Now this 5 does not have an exponent, but they are the same base, so there is secretly an exponent of 1 hiding up there. So this is 5 to the power of 20 divided by 5 to the power of 1, which is going to give me 5 to the power of 20 minus 1, which is 19. So my final answer here is 4 to the power of 6 times 5 to the power of 19. I cannot multiply the 4 and the 5 together because they are bases. They are not coefficients. They have exponents on them, which means I can't multiply them together. So if you join me in the next video, we'll talk about what do I do when I have coefficients.